A hard opening. The machine is cracking. The machine is failing. The sentence is simple. The machine is not a human. It is a network of models and data. It was once a marvel. Now it shows deep cracks. The cracks are financial. They are also technical. They are also moral. The world is watching. This is not idle speculation. Public reports show repeated failures. They show rising costs. They show mounting losses. They show outages that last hours. They show medical misadvice in tests. These are concrete signals. They demand urgent attention. The phrase terminal state is not metaphoric. It is a technical term from research. It means a system that no longer represents reality accurately. It means models that loop on their own output. It means a steady drift into error. The drift can be slow. It can also reach a tipping point. We are close to that tipping point. The signs are visible. The errors are not only embarrassing, they are dangerous. They can cost money. They can cost trust. They can cost lives. We must treat this as a systemic crisis. The money hole, compute and cash burn. Big models are expensive. The costs are raw and immediate. Compute bills run into billions each year. One report, roughly 1.4 billion per year. Internal forecasts, a 14 billion shortfall next year. Analysts, tens of billions in multi-year losses. Those numbers change the calculus. Revenue can be high too. The company may report a large revenue run rate. Yet revenue is not the same as profit. The burn rate still outpaces income in these reports. The business faces brutal choices. It must cut costs or change product strategy. Cost-cutting hits research safety first. Long-term fixes get hit last. Short-term patches get funded. Long-term investments get postponed. That creates risk. It pushes the system toward brittle decisions. When finance meets complex engineering, bad outcomes multiply. Teams may choose expedient methods. They may lean on cheaper data. They may accelerate feature launches. Each choice can deepen technical debt. Each choice can make the collapse likelier. Ads and the loss of trust. Ads are emerging as a last resort revenue lever. Company leaders once rejected ads as a poor fit. Now ads appear in product roadmaps. Ads bring money fast. They also bring a signal problem. Users see an ad and they question motives. Trust breaks quickly. A chat that mixes help and advertising feels compromised. People may stop relying on it for crucial tasks. That hurt compounds the financial problem. The tool loses premium users. The tool loses enterprise customers. Ads also change usage patterns. They may encourage high-volume interactions. They may encourage low-value interactions. Those interactions burn compute and create noise. They strain APIs and raise costs for everyone. The system becomes less sustainable. The choice to add ads is more desperate than strategic. It is a sign of deeper stress. It signals that the company is trying to patch a leak rather than fix the hull. Model collapse. A technical nightmare. Model collapse is a real and documented phenomenon. It happens when models train on model-generated content. The output then becomes the next model's training data. Over time, diversity shrinks. Nuance disappears. Errors amplify. Research papers describe irreversible defects from this loop. The tails of the original data distribution vanish. The model loses rare but vital knowledge. It becomes overfit to synthetic patterns. It gains confidence in wrong answers. Practically, collapse looks like growing hallucinations. It looks like repeating mistakes. It looks like creativity falling flat. It becomes harder to correct because the model's worldview has shifted away from reality. Simple retraining may not fix it. If the majority of public text is eventually synthetic, the ground truth itself shifts. The model may then believe fabricated histories and fake facts. Fixing that requires fresh, high-quality human data. That data is scarce and expensive. Section 5. Data poisoning, contamination at scale. Data poisoning is deliberate contamination of training sets. Bad actors can seed false narratives online. Those false narratives can creep into public repositories. They can then be absorbed by models years later. Investigations have shown propaganda mass-produced articles entering major platforms. Those contaminated sources appear in search results Wikipedia social feeds. Models trained on this mixed content learn the lies. Even trace amounts matter. The danger is magnified by scale. Models train on immense corpora. They cannot be fully audited. A small, well-targeted campaign can nudge a model's behavior. The lag between content creation and model training means attacks now will manifest later. That delay makes detection and response harder. Well, containment is hard. You cannot easily remove poisoned content from the past. You cannot reliably identify every tainted source. The result is a creeping corruption of model outputs. That corruption blends into legitimate information until it dominates. Outages have been frequent and severe. Public status pages recorded multiple long incidents in early 2026. Some failures lasted hours. One outage stretched into many hours across consecutive days. Users lost access to critical features. These outages are more than blips. Reveal engineering fragility. Show operational overload. Show scale is not fully mastered. Disrupt workflows. Erode confidence. Customers shift to competitors. Enterprise partners demand explanations. Investors grow nervous. Support costs rise. The service becomes a liability. Operational stability is a backbone requirement. When it breaks, everything else is at risk. Engineering teams scramble between firefighting and long-term fixes. That pattern breeds burnout and more errors. AI failures have human costs. Medical advice gone wrong can kill. Independent tests have shown alarming patterns. In clinical vignettes, a prominent chat system failed to recommend emergency care in nearly 30% of critical scenarios. It advised monitor, follow-up, where urgent care was needed. Specific cases included stroke-ruptured ectopic pregnancy. Instead of urging immediate emergency care, the model sometimes offered non-urgent alternatives. Clinicians flagged these results as dangerous. The tests were run by medical teams using standard vignettes. The findings were stark. These failures are not theoretical. They show the model producing plausible-sounding but unsafe guidance. The issue is consistency. The model occasionally gets clinical reasoning wrong. When lives are at stake, occasional is too often. We must treat such outputs as harmful. They require mitigation. That includes human oversight, stricter guardrails, explicit disclaimers. It includes building systems that defer to professionals on high-risk questions. The ecosystem is tightly coupled. Many startups rely on large models via APIs. Those startups are often thinly capitalized. They depend on low-cost access, fast growth. If wrappers fail, the platform loses customers and revenue. Reports suggest a large share of these startups will not survive. Rappers burn cash serving heavy free users. They rely on conversion to paid tiers. If conversion fails, the rapper dies. That death removes an API customer for the core provider. This is a feedback loop. Core provider revenue drops. It tightens access, raises prices. That causes more rapper failures. The ecosystem contracts. Innovation slows. The market becomes fragile. The industry can collapse into a smaller set of services. The industry can collapse into a more centralized set of services. That concentration brings systemic risk. It also concentrates failures. A single major collapse could ripple through many sectors. The warning is stark. A major AI system can slip into a terminal state. Financial strain, model collapse, data poisoning, outages, real harms. The result is loss of trust. The cost is human and economic. Practical steps are clear and urgent. First, protect training data, track provenance, label synthetic content, remove or quarantine poison sources. Second, change economics, limit free tiers, avoid ads that distort incentives, charge sustainably for heavy use. Third, enforce safety audits, test on clinical vignettes and critical scenarios, require third-party audits, public transparency reports. Fourth, invest in human-created high-quality datasets, pay for curated content and expert annotations. Finally, regulate where necessary, require incident reporting, fund independent research on model collapse and poisoning, support robust monitoring tools. Act now. Delay deepens the damage. The silicon mine must be tended before it breaks.